Hello everyone, my name is Loman Kang, matrix number 310011. I'm going to do the introduction and problem statement part in our project. So the introduction of our project is integer linear programming, which is ILP, is a class of optimization problems in which some or all decision variables are restricted to integer values. Integer linear programming models are widely applied in operations management, logistics, production planning, and resource allocation where fractional solutions are not feasible in practice. In this report, we use integer linear program to decide how many sustainability projects to implement so PR, which is public relation impact, is maximized while budget and sustainability targets are satisfied, and explain the solution approach using Microsoft Excel solver. So now let's come to the part of problem statement. Texmart is a local owned big box retail chain in Texas with 75 stores, mainly operating in Dallas-Fort Worth area. The goal of Texmart is to invest in sustainability projects to improve public image while reducing greenhouse gas emissions and operating costs. There are 5 project types available, which are solar power installation at stores, wind power installation at stores, replacing delivery trucks by hybrid trucks, waste reduction and recycling initiative, and also plastic bag reduction. The decision problem is to decide the number of projects of each type in order to maximize public relations impact while meeting targets and budget limits.
Good day everyone, my name is Dinesh. I'm going to explain about the objectives. Our main objective is to ensure that sustainability initiatives are implemented effectively while balancing impact and practically. We aim to maximize total media and public relation impact so that our efforts are well communicated and positively received by the public. At the same time, we focus on achieving minimum targets for greenhouse gas, GHG reduction, cost savings and energy savings to support environmental and financial sustainability. It is also important for us to stay within the available budget to ensure feasibility and responsible resource management. Finally, we will respect minimum implementation thresholds and maximum feasible limits so that all action remains realistic, achievable and aligned with existing constraints. Thank you.
So now I will explain about the model formulation. So for the model formulation, let's assign our decision variable first. Here we have the x1 equal to number of solar power project, x2 equal to number of wind power project, x3 equal to the number of hybrid vehicles replacement, and x4 equal to the number of waste or recycling project, and last but not least, x5 equal to number of plastic bag reduction project. Next, let's see the objective function for this problem. So Texmart aim to maximize the total public relation impact from its sustainability initiative. So we maximize z equal to 3x1 plus 2x2 plus 1x3 plus 1x4 and 2x5, where z represents the total PR score. Next, let's look at our constraint. Here we have 7 constraints. The first constraint is the budget constraint, which must be less than or equal to the 30 millions. Second constraint is the GHG emission reduction constraint, where it must be greater than or equal to the 250,000. The third constraint is the annual cost saving constraint, where it must be greater than or equal to 4 millions. And the next constraint is the energy saving, which must be greater than or equal to the 5 millions. In addition, we also have the minimum implementation threshold constraint, where x1 must be greater than or equal to 1, x2 must be greater than or equal to 3, and x3 must be greater than or equal to 10, and x4 must be greater than or equal to 2, and lastly x5 must be greater than or equal to 6. Furthermore, we also have the maximum feasible limits constraint, where x1 must be less than or equal to 75, x2 must be less than or equal to 75, x3 must be less than or equal to 165, and x4 must be less than or equal to 75, and last but not least, x5 must be less than or equal to 75. In addition, we also have the non-negativity constraint, where x1, x2, x3, x4 and x5 must be greater than or equal to 0 and integer.
This slide shows the final result of our optimization model. Our objective was to maximize the value of solution Z. Based on the solver results, the maximum value achieved is 93, which is shown in the objective cells. To reach this optimal value, the solver selected specific value for each decision variable. Solution S1 equal 1, S2 equal 26, S3 equal 24, S4 equal 2, and S5 equal 6. All variables are integers, which means the solution meets the problem constraint and requirement. Therefore, this combination gives us the best possible outcome under the given limitation.
In conclusion, this study shows that integer programming is a powerful tool for supporting strategic sustainability planning. By formulating Texmart's decision problems as an ILP model, the company is able to objectively balance financial constraints with environmental goals and public relation outcomes. The results suggest that diversifying investment across different types of sustainability projects provides the greatest overall PR benefits while still achieving key targets for cost, energy, and emission reduction. Overall, the findings highlights that tools like Excel Solver are practical and effective for solving real-world integer programming problems of moderate complexity, helping organizations make more structured and impactful sustainability choices. Thank you.